Yes, I'm Hwijung Ryu. I'm a leader of a team at KT called Large AI Technology Development. My team is responsible for developing and training large language model. First, it's my great honor to present our works here. Today, I'm going to talk about KT's large AI technologies. First, I'd like to introduce KT's AI-based services. We are challenging new business areas with our AI technology. We are applying our AI to smart factory, mobility, robotics, media content, and some security applications and so on. We also have solutions like AI contact center, Gigajini, a smart speaker, AI robot, and metaverse services. Our core technologies are mainly divided into four. Probably everyone here will be familiar with these names. Large AI is large language model. Recently, it's a foundation of all AI technologies. NLP, natural language processing, for better understanding and then generation of human language. Speech means all technologies of a human voice. Computer vision is technology that can understand some visual information. Today's presentation will focus on the first two. We also collecting a huge amount of real-world data, such as voice, text, pictures, and videos. It enables all of these technologies and solutions. Gigajini is the smart speaker and the first AI speaker connected to Internet TV in Korea, and it's widely and actively used with more than 3 million subscribers. The smart speaker offers lots of functions activated with your voice, such as free conversation, control TV, shopping, alarms, and games. To support these various functions, high level of AI technologies are required. So more than 500 AI R&D steps are developing these functions, including myself. AICC, AI Contact Center, is a good example solution showing how we are using those kind of AI technologies. KT operates the largest contact center in Korea, and our voice bot, the AICC, handles customer calls without human intervention based on our cloud servers and AI technologies. More than 80,000 customers were answered only by AI agents a day, which is 40% of total incoming calls. Voice bot understands customers' complex and even ambiguous requirements about customers' various payment plans, network problems, and memberships, and so on. There is no waiting time, and it's always on. Next, let me introduce our large-scale language model. We call it MIDM in Korean. Large-scale AI is a model that can be used to understand or generate a language by training a large size neural network. Recently, many companies, include some tech giants like Google, are developing large-scale AI models. From million parameter size models to more than hundreds of billion size models are being developed. In addition, it's expanding to a multimodal model that includes not only language, text, but also some visual information. Training a model of that size requires a very large amount of GPU servers and data. For example, training a 175 billion scale GPT-3 model requires at least $2 million. Why do companies develop large-scale AI at such a cost? Because large-scale AI models have already surpassed human language and visual perception performances. Many AI experts say this will become the foundation of all AI services in the near future. For developing AI contact center, I mentioned in section 1, it's necessary to develop our own large AI language model. Our large AI model called MIDM is used as a foundation model to develop many voice and language-based services. It allows us to create services more efficiently than any other technologies in the past we are used, like rules, patterns, machine learning, and some statistical approaches. We used an encoder-decoder structure that is good at both language understanding and generation, and it's optimized for Korean language. Let's talk about some of its main features. These are the points we took into consideration when developing the model. Just to mention a few, it's a general language model for Korean to improve the level of core NLP performance, such as language understanding in a lot of different domains. It's much more effective to use pre-trained language model and fine-tuning it than any other training method. It's also important goal to shorten training time to deliver AI models to new domains. Collecting a large volume of training data for all tasks takes too much time. Therefore, it's necessary to reduce the train time using relatively small data with efficient fine-tuning technology. And also, proper optimization for Korean language is also needed. Currently, many language models available public do not consider the unique characteristics of Korean language. We are also training model that can run on low-end GPU with small memory. We are also leveraging knowledge outside the model. It's very expensive to retrain the entire model for new knowledge. So it's effective to search the necessary trending knowledge in outside documents. We consider some aspects of ethics for this high-quality data set, and some filtering skills techniques are also required. We put much effort on preparing high-quality data. Even after AI models and services are delivered to customers, the model needs to be refined using new data. To prepare a good quantity and quality data, well-defined processes are also required. For example, personal information should be masked, low-quality documents should be discarded from training data, and duplication should be eliminated. We automate the data refinement tasks. NLP is the field where the large AI, large language model, can be applied most easily and effectively. Some of these are not possible without large language model, and some has resulted in significant performance gains, especially the ability to generate natural and fluent text seems impossible without large language model. In the next slide, I will show some practical examples where our language model is used. Case 1, data augmentation. So data augmentation is essential for AI service development for quick start when the data is not enough. Medium, our language model, is used to paraphrase sentences. This enables faster service delivery. In the past, we had to create data one by one to train a new model, but thanks to automatic paraphrasing, you can start with a small amount of data and increase the size of it with no or less effort. It greatly reduced the time and cost of training a new model for the first time. This is a web page we are using. You can create many sentences with the same meaning but different expressions by inserting the original sentence over here, and you can create many sentences you want. Case 2, customer call summarizer. In contact center, every customer service call should be summarized by human agent now. Our large AI automates summarization to save time. Given a multi-turn transcript, large AI generates a one-sentence summary. Compared to the past pattern matching method, it summarized more concise summarization results. It saved at least 15 seconds a call. We handle 80,000 calls a day, I mentioned above. This is an example of a transcript of a customer call. This long transcript summarized into just one sentence. Large AI creates a single sentence by combining scattered information above. We only use 60,000 data for training. Last case 3, toxic content classification. You need to remove toxic content from your training and training data for pre-training and fine-tuning. In addition, you must ensure that the inference results do not generate any improper responses. Large AI-based toxic classifier determines whether there is a potential harmful information in a given text. We collected a large amount of harmful content to train this classifier based on the large language model. And we continue to collect data. In a given sentences, our classifier determines whether they contain harmful information. In the slide, this green normal tags means the sentence is safe, and red toxic tags means there is potential harmful information in the sentence. For example, biases about skin color, generation, gender, age, and something else. Yes, this is the end, and I hope you can take home some new ideas from my presentation. Thank you for listening.
Thanks for your wonderful presentation, Mr. Ryu. Then let's take a question from one of the Zoom users again. If anyone has question about the presentation, please raise your hand. Do we have any questions about this presentation?
Hi, my name is Hiroki Nakamura from NTT Docomo. Thank you for your wonderful presentation. I have one question about unscaled data. How do you detect unscaled data?
Yeah, thank you for your question. We train multiple binary classifier for detecting various kinds of toxic content. For example, we collect some text including gender bias, and we collect some text including some age or other biases. And we also collect exactly the same amount of data, the normal and safe data. And we train multiple binary classifier detecting all those kind of biases and biases. One problem of this approach is that the standard of ethical continuously changing. So we collect data continuously and refine the trained data also continuously.
Thank you for your answer.